Right, FRQ 2 of Calc BC 2025, arguably one of the challenging questions. Um, let's read this out. Curve C is defined by this is a curve C that has a polar equation this between 0 and pi, and there is another semicircle that has an equation of r equal to 1/2 also between 0 and pi. This is calc active question, so we have to find the rate of change of r with respect to theta, that is dr over d theta, of the curve on the curve C at this point and show your setup. That's pretty straightforward. So I'm looking for dr over d theta, right? Dr over d theta at theta equal to 1.3. So all I have to do is just differentiate this 2 sine square theta. So 2 is going to come out, and the derivative of sine square theta is 2 sine theta cos theta, and that's about it. So this will be 4 sine theta cos theta. So I'm just gonna plug in the value of theta as 1.3 in Desmos. So that's gonna come out as 1.031. Okay, let's move on to the next one. Next, we are looking for the area of the region that lies inside C but outside the semicircle. Right, here we have to be very careful here, because although it looks like it could be straightforward, but we need to integrate two functions. The first function is from between these two blue lines. So this is where your semicircle comes in. But remember that don't forget this particular piece. So it's going from 0 all the way to this point that we have to find using calculator. So this area should not be missed. So all we can do here is just take the right side and multiply that with 2, right? So let's first find the point of intersection using Desmos. So here you can notice that I plugged in both the equations, but the only difference is I plugged in the rectangular form. So there is no r theta, it is just y and x. And I've restricted x between 0 and pi because that's also the restriction given in the question. So if you look at the points of intersection, the first point is pi over 6 and the next point is 5 pi over 6. So now we have the points of intersection. Let's write the area. Let's write the orange area first. The orange area corresponds to the C surface or the curve. So that orange area is going to look like 1/2 of r squared theta, where r is 2 sine squared theta whole square, r squared d theta, all the way from 0 to pi over 6. That's the orange one. And then the blue area is going to be the half of r square, where r is half, r squared d theta, all the way from pi over 6, obviously, to pi over 2. And we add both of these, and the total area will be twice of that. So total area will be 2 times of blue area plus orange area. Let's plug that in. So you can have a look here, and I have typed in everything. Half of the first area, then half of r squared d theta. The only difference is the theta is x. Type this in and multiply it by 2 as well, and that's the number that I have. But coming back to our work, we need so let me write this number here. The area that we need is this thing, which is actually the remaining area, right? So what we can do is we can find the total area of the surface C, of the curve C, from here to here, and subtract the green one that we just found, right? What is the total area of C then? The total area of C is going to be integration from twice of integration from 0 to pi over 2, half of r squared d theta, where r is once again this, and d theta is just dx. So that value comes out as 2.3561. But we need this entire thing minus this. So I can just copy, or maybe a better way to do it. Let's mark this as A. Let's mark this as B, and I'm looking for B minus A. So B minus A is 2.067. That's our answer. So the yellow region will be 2.067 over here. Right, now it can be shown that dx over d theta is this. For 0 to pi over 2, what is the value of theta which corresponds on the curve that is farthest from the y-axis? So farthest from the y-axis is as simple as the x-coordinate, right? The x-coordinate. And that's why they have given us the derivative, because we know that wherever the derivative is 0, we have a critical point, and that can have the maximum or a minimum value. Over here, we are also looking for minimum values because minimum is just in the negative direction, but that's fine. We are just looking for the distance, so that will also work. Right, so if I type that in, the value of dx over d theta in Desmos, I'm going to get x-intercepts as shown here. So these are the critical points, and now we are going to use candidates test. For the candidates test, I'm looking for the value of x, that is r cos theta, and r is already 2 sine square theta, so it's 2 sine square theta times cos theta. These two are the critical point, and then I have to put an end point as well, that is pi over 2. And now I'm just going to use Desmos to find all these three values. All right, so I type this in, and I'll just click on this gear symbol and click on the table, and now I can sub in the 0, 0.955 and pi over 2. So it will actually give me a table, and clearly the maximum value, I mean these two are 0, obviously the answer is 0.76, well that's 98, so I would say 0.770. So 0, 0, 0.770, that's going to be the maximum distance. The last part, they're asking that a particle travels along the curve C so that d theta over dt is always 15. So find the rate at which the particle's distance from the origin changes with respect to the time when the particle is at the distance from the origin is basically just the value of r, right? And that's already given to us as 2 sine square theta. So all I mean to do, this is an implicit differentiation. R is 2 sine square theta, and they are looking for dr over d theta. Dr over dt. So dr over dt will be 2 times 2 sine theta cos theta using the chain rule, and the derivative of theta is d theta over dt. So 2 times 2 is 4. I just put that in Desmos, which is theta is 1.3. This theta is also 1.3, and d theta over dt is 15 always. If I type that in Desmos, I'm going to get 15.465. So this should be our final answer for the last part. Alright guys, I hope you liked this video. If you did, please like and subscribe. If you need private tutoring, feel free to reach out. Thank you.